Now we'll start acids and bases. We're going to use the Bronsted-Lowry definition of an acid and base. And an acid is defined as being a proton donor, and a base is defined as being a proton acceptor. So an H plus ion is a proton because a hydrogen exists. It's just a proton and electron. You take the electron away and you have the H plus ion, so all you have is a proton left. So let's consider an acid and its reaction in water. So we'll consider the strong acid HCl, and if we take hydrochloric acid and put it in water, this is an acid, so by definition it is a proton donor. Now water here will act as a base, a proton acceptor, so this will give us H3O plus because water has accepted a proton, and then we'll have the chlorine minus ion left. So this is called the hydronium ion. And Cl minus in solution is basically a spectator ion. It doesn't participate in any further chemistry in this reaction, so it just is solvated and does not participate in any further chemistry. Now let's consider the base, ammonia, NH3. So if we put NH3 in water, ammonia is the base. Water is going to act as the acid in this case. So a base is a proton acceptor, and so it will accept a proton from water, and the resulting ion will be the NH4 ion, NH4 plus, and what's left over from water will be the OH minus ion. Here we have where you can see water, H2O, can be both an acid or a base depending on what is in solution. So if there is a stronger base than water will act as an acid. If there's a stronger acid than water will act as a base. Now another term we want to use and be familiar with is, let's consider the weak acid, hydrogen fluoride. It can react with water to produce H3O plus and the fluorine minus ion. So HF is an acid. Water is acting as a base because it's accepting a proton, and this fluorine minus is called the conjugate base of the acid, and this is called the conjugate acid of the base. So here's a pair, a base and its conjugate acid, and the other pair is a acid and its conjugate base.